Hello, viewers. Yes, you're welcome back. In this class, we're going to continue from where we stop on indices. In our previous class, I made the laws. I state all the laws of indices, and in this class, we're going to carry out their operations. So here, what we'll be doing here is that having understood the laws, here we start putting questions that are related to the laws and see how we can resolve them. Okay, now our first example here, let's look at this. Example 1. Example 1 says simplify 125 raised to power minus 1 over 3 times 25 raised to power half. Okay, here one thing we have to understand in the operations of indices, we must also know our prime numbers. You know how to express number as the product of their prime in index form. What I simply mean here is this. For instance, this 125, we can look for a prime number that can divide 125. These are prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, so forth. Okay, so in most cases, when handling questions on indices, a good idea of a prime number, how to express number as a product of their prime in index form, is very essential. So here is very important that we know that. Now 125, we know 5 can divide it, so it means 5 times 5 times 5. Here, as a product of their prime in index form, means we are saying 5, 1, 2, 3, 5 raised to power 3 is the equivalent form of 125. So here, in place of 125, we replace it with 5 raised to power 3. Here we also have another power here before, minus 1 over 3. So what we usually do, you multiply it by minus 1 over 3. Okay, that's what you do. Then here we have a 25. Our 25 here is 5 square. 5 times 5. 5 times 5. As a product of their prime in index form, we simply means 5 square. And we have a half here, we see times that half. Okay, so here this 3, we cancel this 3 and we'll be left with 5 raised to power minus 1. Here 2 cancel 2, we left with 5 raised to power 1. Okay, and what is now what we have just done with our try to make the base the same, because the bases are not the same. That is the essence of what we have just done. Okay, now the bases are the same now, and we look at the operation side here is multiplications. So multiplication, we said that once the sign is multiplication, all we do is that we take the base as 1 and add powers. Our power is here is minus 1 plus 1. Minus 1 plus 1 is 0. So this means 5 raised to power 0. And we also said in the operation of the law that any number raised to power of 0 is equals to 1. So 5 raised to power 0 is 1. So in this question now, our answer is exactly 1. Okay, that is the first question before us. Now let's look at another question. Let's look at this question. If we have example 2. Example 2, it says simplify s raised to power 5 divide s raised to power minus 2. Okay, let's look at these questions. Here is very straightforward. The bases are the same. You identify the base first, they are the same, and the sign here is divisions. And the rule says that if the bases are the same and the sign is division, what you need to do, you add the power, you subtract powers. So the powers here is 5. Because of this division sign, you say minus, and this one is minus 2, minus 2. So minus minus here will become plus. So here we have a x raised to power 5 plus 2. So s raised to power 7. So we say therefore s raised to power 5 divide s raised to power minus 2 is equals to s raised to power 7. Because division, if the bases are the same, we subtract. Okay, that is one question. Now let's pick another question here. Let's look at another question. Another question. Example 3. It says simplify. Example 3. Simplify 4 raised to power 1 over 3 times 5 raised to power 2 over 3 all over 10 raised to power 2 over 3. Here, look at these questions. These questions, there's no common base. There's no common base attached to it. But something can be done here. Here, what do we do? First of all, we try as much as possible to express 4 raised to power 3 as its index form. This 4 raised to power 3, here we can also say is 2 raised to power 2 is 4 times the power there. Here becomes 2 raised to power 2 over 3. Right? Okay. We express this because we are trying to see how we can, manipulate this. Then we put here, this becomes 2 raised to power 2 over 3 times 5 raised to power 2 over 3 divide 10 raised to power 2 over 3. Okay. Now, if you recall, there are two ways we can handle this. If you recall, I said if we have s raised to power a, or we have x times, let's say y, or raised to power a, this one simply means here, this one simply means s raised to power a times what? Y raised to power a. So what we are saying here is this. As pertain to this, we can say this one is 2 times 5, open bracket 2 times 5, because the powers are the same. We can bring it outside here, become 2 raised to power 3. Okay, now 2 times 5, open bracket 2 times 5, all raised to power 2 over 3. Then at our denominator we have a 10 raised to power 2 over 3. Here we can say 2 times 5, that will give us 10. And if we do that, this becomes 10 raised to power 2 over 3 all over 10 raised to power 2 over 3. So we have to be able to make the base the same. Make the base what? The same. Okay? So here we can use our normal operation. Here, this one will be 10 is the common base. This is division's line. So division will subtract the powers. That means this will become 2 over 3 minus 2 over 3. That is 10 raised to power 2 over 3 minus 2 over 3. That will give us 10 raised to power 0. And any number raised to power 0 is equal to 1. So this question here, our answer is 1. Okay? That is one question. Now let's look at another example. Let's look at another example. You see, okay, imagine we are given this. You see, simplify or evaluate 81 raised to power minus 1 over 2. Okay, times 16 raised to power 1 over 4 times 36 raised to power half. 36 raised to power half. Okay, so we should evaluate this. How do we easily manipulate this? How do we handle this? Okay, let's look at this. How do we attend to these questions? Now, the 81 here, we can express 81 as a product of its prime in the index form. So our 81, we eventually, this is 81 raised to power minus 1 over 2. Okay, so here we can express this as a product of its prime in index form. And here 3 can divide 81. So here we see 81 here is 3 times 3 times 3 times 3. Okay, that will give us 3 raised to power 4. Right? 3 raised to power what? 4. So this 81 raised to power minus half becomes 3 raised to power 4 times minus half. This have 2 times minus 1. The result here will be 3 raised to power minus 2. And you know from indices, negative indices. Negative indices. Here, this one simply means 1 over 3 raised to power 2. That means this is 1 over 9. So our 81 raised to power minus half is equals to 1 over 9. So we'll keep that result. Then let's go to this 16 raised to power 1 over 4. We can also express this as 16 as a product of its prime in index form. What do we do here? We'll say this is our 16 here is 2 times 2 times 2 times 2. That means this is 2 raised to power 4. So we express our 16 raised to power 1 over 4 as 2 raised to power 4 times 1 over 4. Okay, what happened here is this. We go with this. And we'll be left with just 2. So we have seen that 16 raised to power 1 over 4 is the same thing as 2. That is the result there. Right, the final one here is 36 raised to power half. And our 36, we can express it as 3 times 3 times 2 times 2. So here we can say it's 3 square times 2 square. Alright. And here we can say raised to power half. So this half here, we multiply everything here. So this will become 3 raised to power 2 times 1 over 2 times 2 raised to power 2 times 1 over 2. So what happened? This will go with this will go with this, and we'll be left with what? With 6. So here we've obtained all these results. What we need to do now, we need to aggregate. In place of this, the answer is 1 over 9. Times, in place of this, the answer is 2. In place of 36 raised to power half, the answer is 6. Okay, let's look at this. 3 here is 2, 3 here is 3. So here we have 4 over 3, which is the same thing as 1 whole number, or we can say it's 1 whole number 1 over 3. So the whole of that expression is equivalent to that. Okay, all right, let's take more examples. Okay, on the indices. Okay, so let's look at this example here. Let's look at this example. Let's look at this example. You see, evaluate 18 raised to power 3 over 2 times 54 raised to the power minus half, divide 12 raised to the power half. Okay, so we should do this. Here, looking at this question, you will see that there is no clear common base, but with expressing our number as a product of their prime in index form, we will be able to, aggregate some terms. We're going to aggregate some terms. Okay, now let's look at that. Like in our 18 here, raised to the power 3 over 2. 18 simply means 2 here is a 9. That means it's going to be 2 times 3 times 3. Okay, this is 3 over 2. Let's look at our 54. 54 raised to the power minus half. Our 54, 2 can divide it. If 2 divide 54, that means it's going to give us 27. So we're going to be 2 times 27. We can express it. 3 can divide, that means 3 times 3 times 3, which is 9 times 3. So we put it in this form. This one raised to the power minus half. Here divide. 12 is 4 times 3. So the 4, we have to express it as a prime number. So 2 can divide 4. That means it's 2 times 2 times 3. Everything raised to the power 2. So here what will happen, this is 12. This is for 12. Let me specify it very well. This is 12 raised to the power half. It's open bracket 2 times 3 close bracket, all raised to the power half. So here, this one can also be expressed for that 18 raised to the power 3 over 2. This one will becomes 2 times 3. This is 3 square. You close your bracket, raised to the power 3 over 2 times 54 here is 2, open bracket 2. How many 3 do we have here? 3. So it's 3 raised to the power 3. 3 raised to the power 3. 3 raised to the power 3. Raised to the power minus half. Divide. In place of 12 here, this is 2. So 2 raised to the power 2 times 3 raised to the power 1. All raised to the power half. Okay, you can see that we are almost getting there where we have a common base. Okay, here this power will multiply every power in these brackets. So this will have a 2 raised to the power 1 times 3 over 2 times 3 raised to the power 2 times 3 over 2 times 2 raised to the power 1 times minus 1 over 2 times 3 raised to the power 3 times minus 1 over 2 divide 2 raised to the power 2 times half times 3 raised to the power 1 times half. Okay, now we also continue here. This 2, we cancel this 2. 3 over 2 times 2 is 3. So here we have a 2 raised to the power 3 over 2 times 3 raised to the power 3 times here is 2. 1 multiply half minus half, have a minus half times here 3 times minus half is 3 raised to the power minus half. Divide here half times 2 is 1. This one becomes 2 raised to the power 1 times here 1 times half. This becomes 3 raised to the power half. So what we are going to do here is that we see some are just 2, 2, 2, some are 3, 3, 3. So we'll group them. So let's start with the one with 2. So 2, the first 2 there is 2 raised to the power 3 over 2 times 2 raised to power minus half times, okay, here there's division sign here, we say divide 2 raised to power 1. So we group this, then we say times, here is 3, so we come with this 3, we're going with 3 raised to power 3 times 3 raised to power minus half, divide 3 raised to power half. Okay, now we can see that we are having a common base. So in this common base, since the bases are now common, we can perform our operation. But here we look at two operations here. This is time, this is division. So we put all the necessary signs that are needed for the operation. This is 2 as a common base. Here will be 3 over 2. Because this is times, we call plus. We have a open bracket minus half. Okay, here because this is division, so it will give us minus 1. You see times, this times here. Here we take 3 as a common base. Here we have 3 plus, because of this multiplication sign. Here open bracket minus half. Here is division minus half. Okay. Now what we're going to do here, we will leave all this in first. We will do the operation. This one they are already fractions. This is over 1, 3 over 1. So this fraction from the 1, the power, all the powers of 2. The LCM of this fraction is 2. So let's do it there. Let's put it here. The one for 2, the LCM is 2. Here 2 divided by 2 is 1. 1 times 3 is 3. Here 2 divided by 2 here is 1. Plus minus is minus. So 2 divided by 2 is 1, like I said, times 1 is 1. So minus 1. Here 2 divided by 1 here, this one is over 1, is 2. 2 times minus 1 is minus 2. Okay, now if we do this operation, we say 3 minus 1 is 2. 2 minus 2 is 0. So here is going to give us 0 divided by 2. So here 0 divided by 2 is also 0. Okay, so that means the whole of this one now, the whole of this power here, the operation of this power here will give us 2 raised to power 0. Okay, right, so we write it somewhere. Let's put it here. Let's put it here on this bus. Let's put it here. This is 2 raised to power 0 times, well, by the time we come with that of 3, the result we get it. Now let's look at these 3, all the powers. They are also fractions here. So the LCM of this fraction is 2. So 2 divided by 1 is 2. 2 times 3, that will give us 6. Here plus minus is minus first. 2 divided by 2 is 1. 1 times 1 is 1. 2 divided by 2 here is 1. 1 times 1 is 1. So there's minus sign there. So here, let's look at this. Okay, let's look at this. 6 minus 1. 6 minus 1 is 5. 5 minus 1 is 4. And here will be 4 divided by 2. Our answer will be what? Will be 2. So on the whole of this power here, this one will be what? 3 raised to power 2. And here 2 raised to power 0 is 1. And 3 square is 3 times 3, that is 9. So our answer is what? 9. So the whole of this question now, our answer tend to be 9. Okay, I think this where we stop for this class. In our next class, we're going to look at more questions on indices. Have a nice time.